Hey guys, let's learn more about derivatives. So today we're going to learn the product rule, and then I'm just going to give you a couple of other derivatives to know. I want you to know that all of those are in your formula notebook that I gave you from IB, so you don't have to have them memorized. If I were you, I would keep my formula notebook open to that calculus page with all of my derivatives on there to reference. Cool. All right, so let's talk about the product rule. So if I have two things that are being multiplied together and I'm finding the derivative of that, I'm going to take the derivative of the first times the second plus the derivative of the second times the first. Derivative of the first times the second plus the derivative of the second times the first. It doesn't matter which one is first and which one is second. It's just kind of the way that I talk it through, so you'll hear that phrase a whole lot during this lesson today. So let's take a look. We want to find the derivative. So we're starting off nice and easy with a problem that isn't so bad. If I were you, I honestly would go ahead and multiply everything by x and then find the derivative, but we're trying to learn, so we're going to leave it like that. So x is going to be my first, and then 2x plus 3 is going to be my second. So what I'm going to go ahead and do is I'm going to underline, oopsies, in the corresponding color. Cool. All right. So here's what we're going to do. We are finding our derivative. So we need the derivative of the first right here. That's what I'm working on. So the derivative of x is 1. Then we're multiplying that by my second. So 2x plus 3. Plus, now I want the derivative of the second, so the derivative of 2x plus 3. The derivative of 2x is 2, and the derivative of 3 is 0. And then we're going to multiply that by f, or the first, and that was x. So this is the same thing as 2x plus 3 plus 2x, which gives us 4x plus 3, which if you multiply through your x on the beginning and find the derivative like we did before, you'll get the same answer. But like I said, we're trying to learn product rules, so we're working on it. I hope that the color coding helps. Okay, cool. On B, so 2x is going to be my first, and x plus 1 is going to be my second. So we're finding the derivative of y, so dy with respect to x dx equals the derivative of the first, the derivative of 2x is 2, times the second, so I'm going to leave that second part alone, plus, now we want the derivative of the second. The derivative of x is 1. The derivative of 1 is 0, so we just ignore it. And then we multiply that by the first. Plain old 2x, not his derivative. So then we're left with 2x plus 2 plus 2x, which will give us 4x plus 2. Okay, let's beef it up a little bit. Oh, that's not where I scroll. That's where I scroll. Got it. Okay, so which way did I have it? Blue first. All right, so x squared will be my first. 2x minus 1 will be my second. Oopsies, I'm sorry, guys. So f prime of x equals the derivative of the first, derivative of x squared is 2x, times the second, plus the derivative of the second. The derivative of 2x is 2. The derivative of -1 is 0. Times the first, so x squared. Cool. So now we'll simplify a little bit. F prime of x equals 4x squared minus 2x plus 2x squared. So we're ending up with 6x squared minus 2x for that derivative. Now let's beef it up even more. So what I'm going to do, because I do this every single time, even if you look at my notes, I do this every single time. I'm going to rewrite, oopsies, I do not need to have that prime there yet. I'm sorry, I'm not taking the derivative yet. I'm just rewriting that square root as x to the 1/2 power. And then we have 2x plus 1 cubed. Okay, so we're going to have a lot of stuff going on here, but we got this, I promise. So x to the 1/2 is going to be my first. 2x plus 1 cubed is going to be my second. So let's get started. I'm going to put a little line there because I'm going to need some extra space. All right, so let's start with f prime of x equals. So derivative of the first times the second. So the derivative of the first, bring down that 1/2. So I'll have 1/2 x to the, subtract 1 from the power. So 1/2 minus 1 is -1/2. Derivative of the first times the second. So 2x plus 1 cubed plus. Now we have to do the derivative of the second. So this guy has a chain rule because I have a function inside of a function. So we'll do the outside first. So remember, we bring the 3 out front and multiply. Leave the inside the same. Subtract 1 from the power. And then we'll multiply by the derivative of the inside. The derivative of 2x plus 1, or the derivative of just 2x, is 2. So here's what we've got so far. We've got derivative of the first times the second plus the derivative of the second. Now we need to go times the first. So times our original x to the 1/2. Feel free to simplify that, but good golly, I don't feel like it, do you? Yeah. So sometimes you're going to have rules inside of rules, and it keeps, it's a little bit difficult to keep track of, but I believe in you. Just take it slow, write out all of your work, and keep your rules right next to you. I think that will really, really help. Oh, too far, Mrs. Davis. Here we go. All right. Now we got some chain rule along with our product rule. This will be fun. So x squared is my first. X squared minus 2x to the 4th is my second. So here we go. Derivative of y with respect to x, dy dx. The derivative of the first, the derivative of x squared is 2x, times the second. So this guy won't change. X squared minus 2x to the 4th. Plus the derivative of the second. So we got a chain rule going on here. For the derivative of just that x squared minus 2x to the fourth, remember we're going to bring our fourth out front and multiply. So we'll have 4. The inside doesn't change. Subtract 1 from the power, so 4 minus 1 is 3. And then we'll multiply by the derivative of the inside. So we'll multiply by the derivative of x squared is 2x minus the derivative of 2x is 2. So here's what we have so far. The derivative of the first times the second plus the derivative of the second. Now we need to take that times the first. So we're going to multiply that by x squared. Okay, let's try the next one. Find the, too far every frickin' time, Mrs. Davis. Find the gradient of the tangent to y equals x to the fourth times 1 minus 2x squared at x equals -1. All right, so we want to find the derivative first, and then we'll plug in -1 into that derivative. So we'll call x to the fourth my first, and I'll call 1 minus 2x squared my second. So let's find this derivative. Derivative of y with respect to x, dy dx, equals the derivative of the first. Bring that 4 down out front, so we'll have 4 x to the, subtract 1 from the power, so third. Derivative of the first times the second. Plus, and then we'll need the derivative of the second. So we have a chain rule again. We're going to need to bring that 2 out front and multiply. Inside stays the same. Subtract 1 from the power, so now it's just 1. Then we'll multiply by the derivative of the inside. The derivative of 1 is 0. The derivative of -2x is -2, so we'll multiply by -2. Ooh, I'm squished. Times my first, which was x to the fourth. Sorry about that. My husband got home and triggered the alarm, so I had to, I was a little distracted there for a moment. Okay, so I went ahead and rewrote that derivative that we just found there in the black. And then, since we are trying to find the gradient of the tangent to that function at x equals -1, I went ahead and plugged in -1 for x right below that. Now, I plugged it into my calculator because, woo doggy, that's a whole lot. I ended up getting -48. That's what I had in my notes. I double checked it. I'm pretty sure it's -48. If you get something else and you double check it, let me know. All right, so more derivatives to know. So these, too far. These derivatives, once again, are going to be in your formula notebook. They're just something to kind of shove into your back pocket and make sure that you always have with you. You know, remember, you'll have that formula notebook with you on the exam, so you'll be fine. So the derivative of sine is cosine. The derivative of cosine is the opposite of sine. If you remember learning about E at the beginning of the school year, I said something about how that is its own rate of change, right? And how that's why E is such a cool number. It's its own rate of change. So the derivative of e to the x is e to the x. Remember, natural log of x, that is the inverse of e. The natural log of x, his derivative is 1 over x. Cool. So let's differentiate these suckers with respect to x. So This is about to be fantastic. So we're going to take the derivative of f of x equals. Remember, whenever we have a constant times a function and we're differentiating, we're just going to bring that constant with us. And then, what's the derivative of e to the x? E to the x, he's his own rate of change. So the derivative of 3e to the x is 3e to the x. Nice? Right. All right, so let's take a look at b. So we have sine of x plus natural log of x. So f prime of x equals the derivative of sine is cosine. The natural log of x, his derivative is 1 over x. In this next one on C, we have natural log of e to the 3x. Now, remember, natural log and e are inverse operations. So since I have the natural log of e to the x, natural log and e cancel each other out. So I'm just looking at y equals 3x and finding the derivative of that. So we're finding the derivative of y with respect to x, dy dx. The derivative of 3x is 3. All right. Over here on D, we have 3x times the natural log of x. So that means that we have to approach this with the product rule. 3x is going to be our first. Natural log of x is going to be our second. So we're taking the derivative of y with respect to x dy dx equals derivative of the first, so the derivative of 3x is 3, times the second, so we'll multiply that by natural log of x, plus, so we have the derivative of the first times the second. Now we'll take the derivative of the second. The derivative of natural log is 1 over x. Times the first, so that original 3x. So now when we clean that up a little bit, dy dx equals, we have 3 natural log of x equals, not equals, sorry, plus. Those x's will divide away. So we're just left with plus 3 at the end. All right. Oh no, they got pushed onto a different line. That's okay, you can tell what I'm trying to say. Here, let's change. Woo. Better. Neato. So we want to write the gradient of the tangent line at x equals 1 of f of x equals x e to the x minus e to the x. Okay, so like I told you earlier, take a breath, take your time. F prime of x equals. So let's deal first with that x e to the x. So we have two things being multiplied by each other, which means that we have to use the product rule. So x will be my first, and e to the x will be my second. All right, so derivative of the first times the second plus. Okay, so the derivative of x is 1. E to the x stays the same. Derivative of the first times the second plus the derivative of the second times the first. So the derivative of the second, e to the x, is e to the x times the first. plain old x. Good deal. Then we have this minus e to the x over here on the end. We're going to deal with him separately. So we have minus. The derivative of e to the x is e to the x. So now let's clean this guy up a little bit. So we have 1 e to the x. Oh, I don't need the 1 there, do I? I have 1 e to the x minus e to the x. So e to the x minus e to the x is 0. So we're really just left with x e to the x. So now we'll plug in 1 because we want the gradient at x equals 1. So we'll have 1 times e to the first. So that will just be e. And leave it like that. Don't put it in your calculator. Leave it like that. E is an irrational number. We don't need to know. All right. Sounds good. See you guys later.